Hi, my name is Gokul Mohan and today I am doing this presentation for the Real World Analytics Assessment Task 2, which is about prediction of wine quality. Coming to the first slide, we can see that it's about the correlation between the variables. Here on the left side, we can see that it's the scatter plot for citric acid and wine quality. Here we can see that the wine quality is maximum between 0 and 0.6. And coming to the second graph, we can see that it's a scatter plot for chloride and wine quality. Here it is maximum between 0 and 0.1. Coming to third graph, we can see that it's a scatter plot for total sulfur dioxide and wine quality. Here the value is equally distributed between 0 and 100. Coming to the fourth graph, we can see that it's the plot for pH and wine quality. Here the value is between 3 and 3.6 and we can see that it's equally distributed. And coming to the scatter plots for alcohol and wine quality, we can see that the value is equally distributed between 9 and 13. And coming to the data distribution, we can see that for the data distribution of citric acid, we can see the citric acid frequency is highest between 0 and 0.1 with the frequency of 140 as the highest value. And coming to the second graph, we can see that it's about the distribution of chlorides. And in this, we can see that the highest frequency is between 0.05 and 0.1. Coming to the distribution of total sulfur dioxide, here the higher frequency is between 20 and 50 with the frequency increasing from 0 to 40 and then gradually decreasing after the value of 40. Then coming to the pH, we can see that the highest frequency is between 3.3 and 3.4 with the highest frequency as 150. Then coming to the distribution of alcohol, we can see that the highest frequency is between 9 and 10 with the frequency increasing up to the value of 10 and then gradually decreasing after the value of 10 with the highest frequency reported as 120. Now coming to the distribution of wine quality, we can see that the highest frequency here is 200 and with the frequency decreasing after the value of 6. Then coming to the transformations applied. For the variable v2, I have applied the reciprocal transformation. It involves taking reciprocal of each value to find the multiplicative inverse, which helps in reducing skewness and normalization. Then for the variables v3 and v5, I have applied logarithmic transformation and normalization. Here we apply normalization to ensure all variables have equal influence in the model, preventing bias towards variables with larger scales. Then for the variable v42, I have applied logarithmic transformation and normalization. Here this helps stabilize variance and normalize skewed distributions. For the variable v6, I have applied min-max normalization scaling. This helps ranges data between 0 and 1, aiding in compatibility and preventing features with larger ranges from dominating those with smaller ranges. Then this is the table for the error measures and correlation coefficients. This is the table for weights and parameters. Then coming to the model description, we can see that for the weighted arithmetic mean, it calculates the weighted arithmetic mean assigning weights to each prediction based on the relative importance. Then coming to the weighted power means, we can see that it achieves similar performance to that of the p equal to 2 weighted power means model, but with more moderate accuracy and correlation metrics. Coming to the weighted power means with p value equal to 2, it achieves moderate performance with relatively low RMSE and average absolute error, indicating reasonable accuracy. Then coming to the ordered weighted average, we can see that this aggregates predictions using ordered weighted average, which allows for flexible weighting of input based on the relative importance. It exhibits slightly highest RMSE and average absolute error compared to other models. Then coming to the importance of the variables, we can see that chlorides are important components found in wine, but originated from grapes and winemaking process. While small amounts are necessary for flavor, excessive levels can create unwanted salty or bitter taste. Coming to the total sulfur dioxide, it is commonly used in winemaking to preserve wine by preventing oxidation and spoiling, but too much can lead to unpleasant odors and potential health risk. pH measures acidity in wine, affecting flavor and microbial activity. Therefore, maintaining proper pH level is crucial for desired wine characteristics and overall quality. Coming to the alcohol, active alcohol content significantly influences wine sensory attributes. However, excessive alcohol can overpower flavors, causing imbalance. Coming to the best fitting model, I have chosen weighted arithmetic mean as my best fitting model due to its lowest RMSE and average absolute error, indicating that it has a small deviation from the predicted and actual values. Also, it exhibits the highest correlation coefficients compared to the other models. Coming to the result, I can see that when I have applied the 5 input values, I got the predicted wine quality as 2.7525, which can be rounded off to 3. And this predicted wine quality falls within the expected range, suggesting an average wine quality. Coming to the best conditions, we can see that the optimal chloride level. Lower level of chlorides are preferable, and the wine quality is often associated with moderate levels of sulfuric acid. Also, balanced pH is crucial for wine quality. Also, wine quality tends to improve with higher alcohol content. Coming to the implications and limitations, we can see that weighted arithmetic mean assign weights to data points based on their importance, enabling a subtle interpretation of the mean. Coming to the second point, we can see that by incorporating weights, weighted arithmetic mean can potentially improve the accuracy of the mean estimation. The ability to assign weights to different data points provides flexibility in representing the influence of each observation on the overall mean. Coming to the limitations, we can see the weighted arithmetic mean may be sensitive to outliers, especially if they are designed disproportionately high weights. Then the effectiveness of weighted arithmetic mean is dependent on the quality of the wine and appropriateness of the assigned weights. The interpretation of weighted mean can be more complex than that of a simple arithmetic mean, especially when the weights are not intuitive or well understood. Thank you.